This is Math 261. This is section 12.1 on vector valued functions, and this is part 3 on page 3. And on this page I want to dig into graphing a couple of vector valued functions. R1 of t is equal to t times I plus t times j. Now remember that t is a real number. And in this case, t is varying from 0 to 1. And so I've chosen, and we could choose more, but I've just chosen 3 values, 0, 1/2, and 1 for t, so we can get a handle on the graph. This is a little bit of a side note, but I just want to point out, because we were talking about it earlier, about the component functions f of t and g of t. They, in this case, are both equal to t. I just emphasize that these are real valued functions, compared to R1 of t itself, which has a vector output, which is this expression right here. Let's go ahead and complete this table. So we have R1 of t is equal to, hang on a second. Okay, so R1 of t is equal to t times I plus t times j. So we have 0 times I plus 0 times j, and that is written as the 0 vector. So here we have the 0 vector, and when t equals 1/2, we have, so what we're doing is plugging in for these t's. We have 1/2 I plus 1/2 j. That is what it is. That goes here in the table. And then when t is equal to 1, we have 1 times I plus 1 times j. So that's I plus j. So let's plot the terminal points of these 3 vectors. First one is here. Second one is 1/2 I plus 1/2 j. So in terms of plotting, we go here, it's terminal point. Okay. We're concentrating on plotting the terminal points when we generate this graph. This, in the backs of our minds, though, is a vector. It's this particular vector in component form, starting at the origin and going to that terminal point. But again, as we plot these, we're plotting the terminal points for various values of t. For this guy, when t is equal to 1, we have I plus j. So that's 1 in the x direction plus 1 in the y direction is here, 1, 1. So as t goes from 0 to 1, this the trace of this graph is starting at the origin, going like this. At 1/2 second, it's there. 3/4 of a second, it would be there. When t equals 1 second, boom, it's there. And it stops. Okay, I say second, I'm assuming t is time. That's the way we want to think about these things. So that's the graph of this vector valued function. Let's go ahead and do the other one. So here we have R2. R2 of t is equal to 1 minus t times I plus 1 minus t times j. And same little table here, same t values to plug in and calculate the output. So here we have for t equal to 0. We're going to plug that in, we're going to get 1 minus 0 times I plus 1 minus 0 times j. 1 minus 0 is 1, so this is I plus j. Now the terminal point of I plus j is, remember I means 1 in the x direction, j means 1 in the y, so here we're starting here. That's the terminal point of I plus j, is what I just plotted. Then we come down to, in the table, t equals 1/2, and we'll have 1 minus 1/2 times I plus 1 minus 1/2 times j. 1 minus 1/2 is 1/2, so this is 1/2 I plus 1/2 j. So the terminal point of that vector is here. And then in our table, the next t value is 1. So we're going to plug that in. We get 1 minus 1 times I plus 1 minus 1 times j. That's 0I plus 0j. So that's the 0 vector. The terminal point of the 0 vector is the origin here. So the way this function is working, if we think about it as motion, in terms of when time is equal to 0, it starts here. And then it goes this way at 1/2 of a second. If time is equal to 1/2 a second, it's here. And then it keeps moving this way. When time equals 1, we end up at the origin. So it's important to understand that time t in this situation is this parameter that's not directly showing up in these graphs, right? These are plots of x and y values, terminal points of the vectors. Time is how it's being traced out. Where does it start and in what direction does it go, okay? There's not a t-axis here, okay? There's an x and a y-axis. And there's a difference between these two graphs, right? If you follow along how we did them, they end up, if you just look at them here in the xy plane, they look the same, but they were generated in different directions. They had different orientations. So the last part of this is to put arrows on these to indicate the orientation. That one was that way, and the second one here was that way.